So the last session will be with Peter Fankhäuser, CEO and co-founder of Anybotics, and Nicolas Sauvage, founder and president of TDK Ventures. They will discuss the next steps of European industrial autonomy, and a very important topic for Europe. Please welcome them to the stage with a round of applause.
Thank you. Hello, everyone. This is the last session, don't worry. Peter, so good to be on the panel with you.
Thank you for having me. Very good evening.
And just so that everyone has a chance to wake up, we are going to start with a video to show your service, because it's not just about robots. Well, good for the video.
I think the video is without sound, actually, so actually, there are sounds, but I just want to, sometimes words and video speak 1,000 words. And so what do we do at Anybotics? We build robotic inspection solutions, so systems that walk through difficult industrial terrain in the processing industry. Imagine electricity, oil and gas, chemicals, utilities, mining. And we're helping people to do a better job by collecting data, improving uptime, and the robot takes over these hours spent of facilities, and then we have the entire software solution to turn this vast amount of data into insights, to flag anomalies, and all of that can be done at the safe distance where one operator can oversee an entire fleet of robots. We're based in Switzerland, a few hundred robots in the field, so already at the scale globally, and it's very exciting to have a discussion with you today, Nicola.
Thank you, Peter. As you can see in the video, you see a really cool robot, but you see a lot of software. And so I think when we think about inspections and robotics, we think about the robot, but we should start with the industrial pain points. What it is that your customers want to do? What are their pain points?
Yeah. When we started the company, we were quite explorative and said, look, here's a cool robot. Who wants this? And what quite soon resonated is customers that called us and said, look, we need the eyes and the ears on site, so data is crucial. And you cannot put for every problem at every location a sensor. It just doesn't scale physically, nor cost-wise. Second, they don't have enough people to do that job. So there's a demographic shift. There's 70% of the people in maintenance are above age 50. They're taking critical knowledge with them, so they're looking for mobile systems to collect that data. And lastly, safety. I mean, people don't want to work in hazardous environments. It's very costly to bring that safety in, and still accidents happen. So these three factors really lead the industry to find novel solutions. And the way we can provide robots that are adaptable to these very difficult environments where you have steps and stairs, confined spaces, that really created the unlock for us.
I think there is one thing, so it's all the pain points, but this workforce, which is basically walking out of the doors, not being replaced. Now, that's the pain points you've just mentioned, a few of them. What about the strategic aspect to it? What is the strategic aspect for your customers?
So what they are optimizing is uptime. Every hour that a customer loses is hundreds of thousands. Imagine huge facilities, BASF, right, for example, in Ludwigshafen. If a facility stops because a part of the facility stops, it's very, very costly. So how can they optimize the knowledge that nothing will happen? Now, you can do scheduled maintenance, where you just every time, every week, you replace the oil, the ball bearings, but it's much smarter to do condition-based maintenance, where you know about the information of the site, such that you have a more proactive plan and to do the maintenance. So strategically, it's about optimizing uptime and avoiding accidents.
So I represent TDK Ventures. We're a corporate VC, we're an investor. One of the questions we like to ask is why? And so clearly, we've discussed about industrial robotics for decades. Why now, and why autonomous asset inspections start to become so critical? So why now?
Yeah. The problem was around for decades, right? So that hasn't changed. It has increased in pressure. There's competitive forces around the world. There's an aging infrastructure that needs to be taken care of for longer than it was designed for. But what really changed is the technology that we have today. And one of the breakthroughs certainly is smaller compute, better batteries, and the motors that we develop such that you can build a mobile device. But what really happened is the reinforcement learning of robots such that can move in a much higher reliability level. So AI had a fundamental impact on robotics. Back in the days, we were still programming the robots line by line, and you hit the limitations of the human's creativity, and things were not really on a state where you could mass deploy it. With AI, the systems have gone orders of magnitude better, safer, and that created now the technology such that we can mass deploy also in this industry.
And it's interesting because we see AI as that inflection point. Can you give an example of what was not possible or very expensive to do, and AI is really solving for it?
You have to imagine the worlds that our robots operate in, they change constantly. Now, in manufacturing, you have consistent lighting, you have pick and place, you can do that task. It's very controlled. But if you're outdoors on a substation or an oil and gas rig, there's weather, there's snow with slippery floors, everything constantly changes. And you cannot, so the layers to perceive the environment react accordingly in real time. Just to compute, if you do it in a traditional way, and all the calculations cannot be done. And now with AI, you have the magic sauce of learning, right? Such that it's extremely reliable. So that has been a massive unlock.
Very nice. Let's talk about customers, and maybe we'll go through different type of customers, because you have different success stories depending on different customers. And I think it's important for the audience to understand the full suite of solutions. It's not just one size fits all, it's really different. What does success look like for a refinery?
Yeah, for a refinery, for them, it's explosive atmospheres. So asset integrity explosions is massive. So the problem for them is even they cannot introduce any type of electronics that could cause a spark, right? So your mobile phone, your smartwatch would not be allowed. So it's really contradicting technology, avoiding explosions. And so what we did is then build a specific robot for an oil and gas and chemicals industry, and 90% of those facilities underlie that by law restriction of EX zones. And so for us, this meant taking what we had as a robot and making it EX-proof. Technically, very, very difficult. So imagine the main body is flooded with nitrogen, so no gases can go in. Battery, special chemistry, all the sensors are protected. So even if the robot would fall, no electronics would be exposed. And so for us, it's really going deep, understanding the industrial use case, the restrictions, and build specific systems to comply with the safety restrictions they have.
I remember visiting your facility, and even the legs, even the feet of the robot, even the materials of the robot, it's an end-to-end consideration to make sure you can work in explosive environments.
Yes, and that's very hard to do. And we were also surprised when first the topic came up of an oil and gas customer that said, Peter, can you make this X-proof? And I'm very, very optimistic and says, of course we can, right? Now, 4 years in, it took much longer than we thought. We have now 10 patents on it. But you're right, a lot of the standard commodity equipment that we assume, for example, cooling, we assumed that just exists. It does not exist for that type of robot with that performance, but also that certification level. So we had to invent a lot of the things ourselves, custom cooling, feet, electronics, batteries, all of those things. It's a massive moat, but it really got us down in a big rabbit hole.
I feel like I need to go back to that video. The metal mill, that's also a very challenging environment. What did you solve for?
So in all the metals, you have dusty, hot environment, loud environment. For them, thermography is a major pain point. So hot metal, they have insulation, and if you have one spot that overheats and wears off over time, that could cause a breakout, a whiteout, so when hot metal flies around. So what you don't want is people there.
Yep.
Typically, they would often quickly run underneath and scan by hand. Nobody can and should do that. Then they started using thermal cameras, but you cannot place thermal cameras everywhere, and they burn. So one of our customers burned through 15 cameras a year, and each of them cost 60,000, right?
Yep.
So it's just not an efficient process. So they accepted this as status quo, but now with robotics, you do mobile sensing at the fraction of the cost.
Yep.
People keep people safe, and we're saving them millions in asset integrity and uptime.
And I think it's one good example from that video, which is when it was humans, first, you don't want to send humans there. But two, they are pointing at somewhere, which may not be always the same location. You don't get the same quality. And then the question is, why don't you just use IoT? You put your cameras, they're always there, they're always watching. It doesn't work, they break down. And that's why the robot that can come in and come out really helps. Now, what about a power plant facility?
So in the utility space, for example, so power plants, we have power generation and utilities. I think there is a really nice case. There's thousands of substations in the world. Now, for them, they have the security case, people breaking in, but much more important is, again, asset integrity. So for customers, we look at partial discharge and temperature differences between bushings. Now, one of our customers found the 2-degree temperature difference, and with historic data analysis, we're able to prove that in the past, this caused quite quickly a degradation and cost them millions. Now, what's interesting is, sometimes people think we're taking away work, right? In that case, actually, the unions were extremely happy because they came in, maintained the machine, fixed the machine, it cost them work.
Yep.
They kept the uptime, and they were able to use the same machine, so saving money. So it's a win-win-win situation for all people. Don't let your assets break, fix them while you can.
And they upskill the workers.
100%.
Yeah. Because at the end, these workers start to become managers of many robots. And they manage the solutions, the operating system.
Yeah.
OK, one more example about mining site.
In mining, it's the crushers, very similar, rotating equipment, pumps. So what we do is listen to machines, because when it's visually broken, it's already too late. But the vibration of a machine takes very early a footprint of what's happening. When a human can hear the car or your bike sounds weird, we can do that in the ultrasonic frequency and very quickly detect if there's pump cavitation, if there's a ball bearing running out, and even detect the failure mode. The sound and the analysis of sound gives you a very early indication. That's quite interesting, and you find problems much earlier.
Very nice. So we talked about pain points, why it's strategic, why now. We went through good examples. Let's talk numbers. How do your customers think about ROI?
Yeah. It's really 3 pillars. Number 1, asset downtime avoidance. Now, as I mentioned, every hour is hundreds of thousands avoided. So in these cases I mentioned, it's very quickly in the millions. Second is free up time. So many of our customers use external consultants that come in once a month, a team that does manual measurement and sends them a report. They do it infrequently because it's too expensive.
Yep.
And so with a robot, it's cheaper, more effective. You have all the data, and you have it in-house instead of paying an external consultant to do that. And the last one, which is harder to quantify in dollars, but it's safety. So some customers, they have avoided exposure of people up to 90% to hazardous environments. And the status is, if you can improve safety for people, you'll do it. You don't want to put the dollar sign behind it, but it's always a worthwhile investment.
Now, this one is going to be a tough question, one we haven't prepared, but you're clearly building huge value creation. How about value capture? How are you thinking about it?
Can you explain exactly what you mean by?
So you're creating a huge amount of value for your customers.
Yep.
How do you capture some value for you, Anybotics?
Yeah. So the data that we're collecting and those insights, that's for the customer, that's what they paid for. What we're asking is, can we be part of the data collection and the insights? Okay. So we're going through, we went through ISO 27001 to be able to get the data. We have a trustworthy relationship, so we can train on that data and ultimately understand what worked, what is confirmed, what is not, what is maybe a false positive, yep, and improve the industrial AI engine. Mm. And customers are happy to share that. Why? Because the reliability of the plant is not necessarily a competitive differentiator to others. They actually have quite frequent exchanges and recommend us to even their competition, because they say, look, this helped us. We compete elsewhere, but on the reliability and safety, we want to improve that for the industry. So we're capturing the data, improving the industrial AI engine, and can give that to everyone back as well.
Yeah. As you know, I'm very keen on customers' delight, and you've implemented the Net Promoter Score. And from that, you know how much your customers are recommending you to other customers. Clearly, the value you bring is deeper, and we learned that through the NPS and from your discussion with customer. But can you talk about the operational layer, intelligence layer?
Yeah. Now, just finding problems is not enough, right?
Yeah.
So it's really about who looks at the data, how often. So it's also the training of the data, and then how quickly can you trigger the analysis of a problem to understanding it, approval, and then fixing it. So we're working with companies such as SAP, work order management, or feeding data back into the computerized management system, CMMS. And so for us, we're part of an ecosystem, an API, all of that is extremely important. Otherwise, your standalone solution, where the value is limited. So for us, the partners and ecosystem integration is crucial.
Can you double click on the ecosystem? Because again, people think about robot and they think it's a product. It's a total service and a full ecosystem. How should the audience think about the ecosystem itself?
Yeah. So there is essentially business data, the SAPs, et cetera, of the world, right? Oracle. Then we have process data. That's the existing DCS SCADA system, so the operational set points of the machine and the sensors that they have. But there's asset integrity data. These two, the first two, have been well covered. The third one has been missing and in isolation. This is where people did some Word files, et cetera, just not a systematic process. Yeah. Now we're connecting all three. So suddenly you have an outside, but also inside look of the machines connected with the market needs, the business data. And that becomes very powerful. We can solve, though, only one part. And so that's why we're connecting to both business and process data to even get more out of the machines. So for example, spare parts. They're very costly, right? Mm. So instead of just having them on stock and waiting until it breaks, you know it's about to break, let's order. So just-in-time delivery. That's a massive gain and reducing your stock that you have.
Yeah, it's huge value creation. And the cost, like you said, is when the factory stops. And then you have no productivity for weeks or months or days. So for sure. I want to talk about the question about recurring inspection data versus just the physical event of checking. Can you speak to the value of that recurring inspection data?
Yeah. In the beginning, what we replicated is what humans do, right? Is essentially you look at an asset, and we asked, what's the threshold? What is good and bad? And they couldn't actually tell you. So what they did is, we asked them, how do you do it? Yeah, I just hold my hands on the left and the right pump, and the one that's hot, that's maybe, it's drifting away. And so there's underlying contextual data. How do they behave among each other? Because there's environmental factors. But much more important is historic data. So instead of taking one snapshot, you go back in history, you define what was the desired set point, what was the outside data, and you see trends. And these trends can be very, very slow. So you need to be very precise in your measurements, consistent, and only a robot can do those types of measurements. But then you unlock the historic data analysis, and then you can also start looking to the future. This is where the predictive maintenance becomes an important part.
If anything, this is only now that we get to the promise of predictive maintenance. We are getting to the point where we have the intelligence layer understanding enough to be able to do it right.
Yes, I mean, predictive maintenance has been around for decades. The core problem has been the data. There is successful cases where it's very limited cases you can do predictive maintenance on turbines, but the broad spectrum of predictive maintenance just doesn't exist. Many facilities still are in the planned and reactive maintenance. And now with that consistent, rich data, this unlocks a massive door to take a big step in predictive maintenance.
So maybe here I want to highlight something for the audience. You can see the many verticals that a company like Anybotics needs to do. But not just that, but go very deep into every different use cases to the point of understanding the temperature difference between the left and the right. And that requires a level of intimacy and time spent with the customer, understanding the customer real pain points, not what they say is their pain points, but actually really understanding it. Do you have another example where it was not obvious, you learned something from the customer, and you were like, oh, wow, this is a very different way to solve it?
Yes, I mean, we were astonished just how rudimentary certain things are, right? So everybody talks about digital twin, all of that. They talk about that in the C-level, but then you go and see on site. People use chalkboards, paper. Some person, a reliability engineer, was still waiting for weeks on the report that was done because they go around with two cameras, a thermal camera and a visual camera, 2 SD cards, go back to the PC, copy paste into a Word file, put it into an email, send it. Mistakes, weeks are lost, right?
Yep.
The data is irrelevant at that point.
Yep.
That process obviously can be automated completely.
Now, when we talk about autonomous, there's something which, the concept of continuous awareness, which I think is the next level. Can you speak to that value of continuous awareness across the full industrial environment?
Today, we classify the robot essentially as an inspection assistant, right? You tell it exactly what to look at, and then it can do the job reliably. But problems don't always appear where you expect them to. Cracks are forming, hotspots leakages, they can just happen anywhere. So for that, we're building the next generation of robot that has a continuous inspection capability. Now, there is about 15 cameras on the robot and multiple sensors, so it's a lot of data, a lot of AI processing that needs to happen. You need spatial awareness, continuous awareness. So that's truly, though, the next level where AI can take us, not only in mobility, autonomy of the robot, but understanding of the world, scanning it to the last round, and through that understanding and finding other problems that we can't detect today.
Now, let me be provocative for a second. We all see these beautiful YouTube videos of robots doing dancing and kicking and whatever. But that's the easy part, right? What I think is very hard is how do you win the trust of the customer, especially industrial customers. Can you speak to the difference between these companies doing cool demos and the ones that are delivering jobs to be done that are very hard to do?
Yeah. I mean, there's a counterintuitive in kind of movement in robotics, right? What is very easy for a robot, a backflip, turns out that's very easy to do with reinforcement learning. It's hard for a human. So what happens is people think, wow, if this robot can do a backflip, it can do everything else as well. At the same time, what you do every day, taking a key out of your pocket without thinking about it, has not been done in robotics. Extremely difficult.
Yep.
No vision, right? The hands, the muscles, the tissue, all of that.
Yep.
And so people project in the wrong direction. And of course, as a lot of companies, they want to create the hype. That's also good. I'm not against it, but they project that, super intelligence of systems. But as soon as you're on site with the real people, people actually don't want robots. They want to have a solution to the problem. So it goes much, much deeper. Are robots supposed to be slow, careful, predictable, right? Don't do anything weird. Don't be this AI machine that just does stuff. Transparent, reliable, and safe. That's what matters then ultimately.
And I think you touched on some elements, but clearly you've had many pilots with customers. Then they convert to full commercial engagements. Can you speak to that transition where you can tell you've earned the trust of the industrial operators?
Yes. By now, and we have gone through some difficult cases as well where it did not work out, can the people agree to the problem to be solved? Now, we had cases where the customer, after the pilot, were like, yeah, we don't really see the value. And I go back, and what is the problem we're supposed to solve? It turns out, in average, we need to convince 5.4 people to agree on the problem. Now, if they have different expectations, they will never really come to the conclusion. So we spend roughly half of the sales process to get people in a workshop to ROI analysis, all the background, to make them converge on the problem, and then you build from there. If they cannot agree, we will not really continue because we know you're not going to be happy later.
So we're at DTM26 in Berlin, many founders here. Is there any misconception about winning industrial customers you want to share with them?
Well, there's always the B2B versus B2C, right? Human versus a group, a company, who are you selling to? And I think also the trap we fell in the beginning is that you have a champion who's really bought in, but can he also create the influence and the change of the company? And for sure, right, that's one example. We have a couple of tests. Can that person bring the operations teams in a call, and how quickly? Does he have access to the historic data? So there's a checklist of things that you need to make sure that that person is actually a go-getter, right? Somebody who can create that movement and has the trust. Not only somebody who has been in the innovation department, they say, yeah, he's playing around with those toys, right? So that's a trap that you can fall into. Yep. And so be very careful. Who is ultimately paying for your product? Not the pilot, but for your solution. And are you in contact with them at the beginning?
Very nice. So I'm based in Silicon Valley, but I've invested in you in Switzerland. I've invested in Ineratech in Germany, so I don't need to be convinced. But can you make the case for the investors here why, being in Europe, you can win?
Yeah. You could say, look, the Chinese build very cheap robots and the US is very good in selling, and you say Europe will fail. I see it the opposite, right? Maybe the financial, less investments that we have also invites creativity. So my take is we have tremendous talent in robotics, in AI. We can build high-quality systems. We're trusted with data globally. So there's an advantage here to use potentially Asian technologies produced there, learn from the US and hire people from there to sell, right? So we can combine both worlds, but still have a European brand, and for us, a Swiss brand that is entrusted by customers to actually deliver. Because again, it's not about selling the best, it's not about the cheapest robots, but the full solution that's also promised. And I think there, I take the pride that we can be the leaders from Europe.
And you are taking full advantage of amazing talent locally. Can you speak to the talent in Europe?
Sure. I mean, we came out of ETH Zurich, which is a robotics hub, which is amazing. So we're also maintaining that relationship with universities to always be, we give them robots, they experiment, we see what works, we hire people from there. And so fostering that connection has been extremely relevant to us. We also sell robots to other universities. Again, bring your tools out there, let them learn on it. And sometimes you hire people, they have 4 years of experience on your system, right? So that partnership between industry and academia is something that I think we leverage quite well in Europe.
Perfect. This was Peter from Anybotics. Thank you.
Thank you so much, both of you.
Bravo.